Okay, so here we are. We are at 6.1, Propositional Logic. And there's really three aims of this section. The first goal of this section is really introduce you to the idea that you symbolize whole propositions with just letters. The second idea is to introduce you to the basic connectives, or what we might call logical operators, that link different propositions together, different sentences or statements that are made. And the third idea is the chapter covers is it tries to refine your ability for translating statements using the operators, right? So let's begin with a very easy one. Let's just begin with, let's just talk, since this is a philosophy class, think about something that philosophers often debate and argue about, which is namely the existence of God, right? So let's take the basic proposition, God exists, right? We can symbolize that with a very simple letter, just G, right? God exists, right? Similarly, right, we could also take a different proposition, right? Let's say the proposition, God, that roses are red, right? Right. That could be symbolized with an R. You could also take a proposition, God created red roses, right? And we could symbolize that with C, right? So here we can take, these are all different statements that all mean different things, right? God exists, roses are red, and God created red roses, and we can symbolize them. Now there's different ways of relating these in ordinary language. And so what we need to do is we need to introduce some of the key operations for linking these statements. So let's just put our G, our R, and our C up here for now, right? And so let's just talk about the logical operators. And let me put this in a different color so you know we're talking about something a little bit different. Now let's put this in black. The logical operators. Right. The first logical operator is negation, which is symbolized with the little squiggly line, right? It's located on the upper left side of your keyboard. It's called a tilde, right? And that's negation. The second one, and I'm going to go over these in just a minute, right? The second one is called disjunction. Disjunction is like either or, right? And that's symbolized with the lowercase v, right? The third one, and actually probably should have this first, is the idea of conjunction. And that's symbolized with the little circle, or if you're using it online, you'll see I have an alternate symbolization, which is basically use it as a period, right? Number 4 is what we call the conditional, right? And that's symbolized with the horseshoe, at least in the Hurley book, but since we're using keyboards, we're going to use the greater than symbol, right? But what the conditional refers to is an if-then scenario, right? If-then scenario. Number 5 is called the biconditional. And the biconditional in the Hurley text is symbolized by a triple bar. Now, for those of you doing your homework online, you can just use an equal symbol, right? So here we'd have the lowercase v and the tilde. So the only adjustments we've made is the greater than symbol and the equal symbol and the period with regards to using your keyboard if you want to type in these logical operators. Now, just basically means not or non, right? Such that if I say, let's give our example here. Let's define it. Let's start with the G, God exists. So if I negate that symbol, it looks like this. Namely, this is saying that it is not the case that God exists, right? Or namely, God does not exist, right? Disjunction basically means either or. And in this case, we need at least 2 different symbols. So you'll find that negation is the only operator that only requires 1 letter. With the rest of these, disjunction, condition, the conjunction, conditional, and the biconditional, we always need at least two propositions to deal with, right? So the disjunction would be, say, for instance, either God exists or God does not exist, right? So this would say it is the case that God exists or it's not the case that God exists. It's one or the other, right? And actually, we should make a note here. You'll find a footnote in your book, and that is namely that there's two types of disjunction. There's either the inclusive or the exclusive. And in this case, we'll always be using the inclusive disjunction, which means we can say either or and both. But that's not too important now, but for those of you, you may think of that. Okay. Now, conjunction is when we basically use the term and. We combine things together. Right? So let's say we have God exists and roses are red. Right? So that's what it looks like there. So this says, it's not the case that God exists, or God does not exist. This says God exists and roses are red. Right? We could change it and combine it. We could say negation are, right? God exists and roses aren't red. That's obviously false, but you can see that you can use the operators in many different ways. Now, the conditional. The conditional basically means if, then. Right? It's based on the idea that you have a certain condition that you have to meet. Right? So it would be symbolized like this. God exists. If God exists, then roses are red. Right? Now, obviously, this doesn't really make sense because that's not a condition for roses being red. But what I want you to see is basically how this works, right? Let me give you a different example, right? If it snows, then my feet are cold, right? So this would say S, the proposition would be it's snowing or something. If it's snowing, and then C would represent, not in our case here, it was something about roses being red, God created them, but in this case it means cold. So if it's snowing, then it's cold outside. The key there is that this conditional, represented by either a horseshoe or the greater than symbol, means if then. And finally, there's the biconditional, which means basically if and only if, right? So this would be the case that well, let's go back up here, right? God created roses to be red if and only if God exists, right? Because if God doesn't exist, it wouldn't be a condition for that being so, right? So what the biconditional represents is it represents both sufficient and necessary conditions, the logical conditions, right? Just to remind you, a sufficient condition is a condition that occurs that allows for something to be the case. A necessary condition is a condition that has to be the case in order for a certain effect to take place. A sufficient and a necessary condition is one that's both sufficient but has to also take place. And really, when we talk about biconditionals, we're talking about something like sufficient and necessary conditions. And obviously, these don't necessarily all work out, right? But what I want you to see is namely how you can start to use the operations, right? So let me stop there.